In the last part of the question, it is told to us that a player pays $1 for one throw. Then you notice that it begins to say he receives nothing if the difference between the number of heads and tails obtained is less than 3. He receives $2 if the difference is equal to 3. And he receives K dollars if the difference is more than 3. Alright, so remember the idea of difference, alright, is actually the modulus of the value of x. Okay, so you also notice there are 3 conditions here. Receives nothing, right? If difference between the number of heads and tails is less than 3, so this is a less than 3 value. The second one is $2 if the difference is equals to 3. And the third condition is if it is more than 3. So if we take a look, the difference between the heads and tails is basically the modulus of x. So if you're looking at the modulus of x, they have the values 5, 3, 1, 1, 3, 5. Yeah, so you can observe that there is a pairing of 5, a pairing of 3, and a pairing of 1s, right? So the possible values of modulus x, all right, or rather mod x for the random variable are 1, 3, and 5. Okay, so these are the three absolute values, or rather the magnitudes of difference that we're going to look at for the last part of the question. Okay, so we need to be able to find the value of K if the expectation of the player's profit is $10. All right, so notice we're looking at expectation. So it's expectation of something and it's of the player's profit. So in some sense, you should have a sensing that you're going to look at expectation of the player's profit, right? And it's actually is 10 means it's equals to $10. So let's look at how we can solve this. Right, so since we're looking at differences, I'm going to let D be the random variable, denoting the difference between the number of tails and heads, So D is actually equals to mod X, and we have said it earlier that the possible values of D are 1, 3, and 5 that we have talked about earlier on. Now, then, notice that whatever that is being paid out, all right, is actually the winnings of the player. Okay, so I'm going to let another random variable W be the random variable denoting the cash received in dollars in one throw. So the amount of cash received. So when W is equals to 0, okay, you notice that it's actually 1. Why? Because he receives nothing when the difference is actually less than 3. So 1 is the value less than 3, so 0 equals to 1. All right, and P of W equals to W is P of D equals to D. So actually, I will need to sum up the two probabilities when it's -1 and 1, right? Because if you look at this particular PDF table, if I look at mod X, yeah, mod X would actually be 5, 3, 1, 1, 3, 5. So for me to have P of W equals to W, all right, that will be when mod X equals to 1. So it's actually the sum of the two. That's how you get 20 over 32. All right, and so on and so forth. When D is 3, all right, W must be 2. Why? Because based on the second condition, all right, you receive $2 if the difference is exactly equals to 3. And there's one value of 3, or rather there are two values of 3. So it's 5 over 32 plus 5 over 32. That's how you get 10 over 32. And similarly, when W equals to K, that's when D is equals to 5. You just sum up the two values when mod X is equals to 5 for the probability. Okay, so the expected cash received per throw, this is actually the expectation of W. All right, so this is the formula. So don't forget when you are calculating expectation, always state the formula before you move on to the calculation. All right, so it will be 0 times 20 over 32 plus 2 times 10 over 32 plus K times 2 over 32. All right, because it's the sum of all W's, all right, of W times probability of W, P of W equals to W. All right, the value of 0 should also be calculated as well. Okay, so simplify, this is what you get. And earlier on, we said that we're looking at the expected profit of this person being $10. The profit is the amount of cash you receive per throw. All right, and you actually need to subtract it by 1 because he actually paid $1 to make the throw, right? So this subtraction of 1 is the amount paid to throw. Okay, once. All right, so it is equal to 10. So you calculate K must be 166. Now, so that's one way to solve the problem. The other way is, instead of looking at the cash received, we now look at profit in dollars. All right, the profit in dollars, all right, its values will now, um, instead of the original 0, 2, and K, it now becomes -1, 1, and K minus 1. How do I get these values? This is actually 0 minus 1. This is actually 2 minus 1. And this is K minus 1. Where did all these minus 1s come from? These 3 minus 1s, right, is actually the $1 paid, all right, to make one throw, right? And now when you're calculating the expectation, which is the sum of WPW equals to W over all W, all right, this is exactly the profit now, because you have defined it as profit. Unlike in the original solution, I defined it as the cash received. Okay, but ultimately, I should still get K to be 166, right? And that will end this particular question.